In this project, I will demonstrate how to configure RTC on FPB-RA0E1 board. Open ESK Studio and click on this file icon, then select New, then select Renesas C++, then select Renesas RA project. After naming your project in dialog box, click on this Next button and then select FPB-RA0E1 board from this drop-down menu. After board selection, click on Next button. Here select Executable and No Autos option. After that, click on Next button. Here select Bare Metal Minimal and click on Finish. Click on this Open Perspective button. By default, IDE will open FSP configuration file. Then click on Stack tab. Then click on New Stack. Then click on Connectivity. Then select UART A stack. Then again click on New Stack. Then select Timers. Then select RTC stack. After that, click on Clock tab. Then enable clock source for UART A stack. In Properties window for UART A stack, under Interrupts, you need to define a callback function for UART A stack. After that, click on Generate Project Contents. Then click on Proceed button to open C++ perspective. After that, open HallEntry.c file under src folder. In Project Explorer tab, expand Developer Assistant tab. Here you can find function code related to RTC and UART A stack. From Developer Assistant tab, drag and drop callback function for UART A stack. After that, declare RTC time structure to set and get time from RTC stack. Now I will implement UART callback function. After that, in global space, declare buffer for UART data transfer and receive complete flag. Now I will add RTT source code in this project. You can get the source code by installing JLink for your computer from Sagar website. After that, include common util.h file in HallEntry.c file. This file contains setting related to RTT. In HallEntry function, drag and drop RTC open function call from Developer Assistant tab. Then declare FSP error variable and use assert function to make sure API call was successful. Now from Developer Assistant tab, drag and drop UART A open function call in HallEntry.c file. Then use assert function to make sure API call was successful. Now I will declare while loop here. First I will check if receive complete variable is set or not. From Developer Assistant tab, drag and drop UART A read API call in while loop. Use assert function to make sure API call was successful. In UART read API call, specify buffer name and size. Now I will declare a message array to request time using UART from computer using USB to UART adapter. From Developer Assistant tab, drag and drop UART A write function call in while loop. In UART A write function call, I will send time request and then specify the size of message array. After UART write function call, use assert function to make sure API call was successful. Now I will create a delay using RBSP software delay function call. Create a 5-second delay using 5 in first argument and then in second argument use BSP delay units second. Now we will process UART data when receive complete flag is set to 1. Now define RTC set time function here. Only call RTC set time function when UART receive complete variable is set to 1. Now I will implement RTC set time function call. As I am sending data from PC, I will send data according to variable arrangement in RTC set time function call. Using software serial terminal, first I will send seconds, then I will send minutes, then I will send hours, then I will send day of the month, then I will send day of the week, then I will send the month, and finally the year. From Developer Assistant tab, now drag and drop RTC calendar time set function call here. In second argument, you need to provide the address of RTC structure variable, then declare FSP error variable and use assert function to make sure API call was successful. Instead of requesting time every 5 seconds, we will only request when MCU reset. Now from Developer Assistant tab, drag and drop RTC calendar time get function call in while one loop here. In second argument provide the rest of RTC get time structure variable. Use asset function to make sure function call was successful. Use app print function to send current time stored in RTC get time structure variable. In Project Explorer tab, click on your project name, then click on this hammer icon to build your project. After build is successful, then right click on your project name, then select debug as, then select Renesas GDB hardware debugging. Click on switch button to switch to debug perspective. Now click on window, then select overview, then select expression tab. Here add first 7 bytes of data UART and then enable real-time update by right clicking on the expression name, then selecting real-time update option. I want to show a error condition here you might have. After expressions are added, you can press the resume button again. Open any software serial terminal to send data to hardware. Here you can observe that when we send string data, we are receiving string data accurately. But when I try to send hex data, I receive garbage values. So you need to enable the hex option in software serial terminal. Now you can observe we are receiving data accurately. Now you need to find Sagar RTT address. You can find that in .elf file under binaries. Open .elf file and press Ctrl plus F to search for underscore Sagar. Now open Sagar RTT viewer and connect via address found in .elf file for underscore Sagar RTT. Here I have listed down the byte sequence according to my program from first byte to the 7th byte. Just want to mention here we are sending data in hexadecimal form, but in our hardware it will be received as decimal data. Now connect with RTT viewer again if disconnected. After message date and time updated, you can observe the real-time clock data which we send via UART terminal. In this example, you can also observe the date change. You can use any serial communication like UART, I2C and SPI to update your RTC data according to this example.